Continental drift and seafloor spreading. Part 1. A controversial theory. In a 1912 lecture, German-born meteorologist Alfred Wegener proposed the idea of continental drift. His idea came from two observations. The continents seemed to fit together like a puzzle, and fossils of animals found on coasts of different continents also aligned. The original landmass he referred to as Pangaea, which meant all land. Ideas that supported Wegener. Puzzle pieces. The way that the continents fit together. Fossil records. Locations of fossils on continents that would have fit together. Geologic records. Nearly identical rock layers on continents that would have fit together. Climate change. Plants that live primarily in warmer regions found on multiple continents, including Antarctica. If Pangaea were true, the continent would have been a warmer climate, allowing for that plant to survive. Wegener gets denied. Alfred Wegener had a major hole in his theory. He could not explain how, why, or when this occurred. Wegener proposed that the spinning of the Earth somehow caused the continents to move, that they had plowed through the oceans. This idea was quickly shot down by physicists and geologists. The Earth's spinning cannot cause less dense continental crust to plow through more dense and rigid oceanic crust. Wegener's idea was rejected by the scientific community and would not be revisited until after his death. Part 2. Seafloor spreading. During the 1940s and 50s, there were huge advances in technology, specifically in the use of sound waves. Scientists began bouncing sound waves off the ocean floor in an effort to make a map of the ocean floor. This led to a major discovery. In the middle of the Atlantic, Pacific, and other oceans around the world was a chain of mountains and rift valleys. These are now referred to as mid-ocean ridges. We often refer to the one present in the Atlantic as the Mid-Atlantic Ridge. Where do you think these ridges came from? Harry Hess. In the early 1960s, Harry Hess, a Princeton University professor, proposed his now famous theory. Harry's theory is called seafloor spreading. Hess proposed that less dense basaltic magma from beneath the Earth's crust was pushed upward through the denser ocean floor. The seafloor was then forced outward from the opening, spreading the seafloor apart. Evidence for spreading. In 1968, the Glomar Challenger began collecting samples from the ocean floor that would support Hess's theory. Scientists collected rocks from the ocean floor and also drilled samples from different distances between the ridge and the coastline. Scientists found that the youngest rocks are found along the mid-ocean ridge and became increasingly older as you move outward toward the coastline. These findings supported both Hess's theory of seafloor spreading and Wegener's theory of continental drift. More supporting evidence: a magnetic timescale. When rocks containing iron cool, the iron aligns itself with the Earth's magnetic poles, much like a compass does. Scientists have determined that the Earth's magnetic poles have reversed multiple times. Looking at the seafloor iron-containing rocks, they flip their polarity as you move away from the mid-ocean ridge. In other words, the seafloor spreading theory fits perfectly with another theory scientists have had for some time.